Hello, hello. I believe we are live. Welcome to another Hood episode. I am so excited this week. I think this is our third episode. If you recall, we had the big Istio Ambient Mesh announcement. So on the first day of the announcement, which is Wednesday, we did a particular Hood about Istio Ambient Mesh and what it mean to you? So we did a hood with guest speakers from Google and also a few speakers from Solo. So check it out if you haven't. It was a celebration of Istio Ambient Mesh and also discuss, what it means to you as an Istio user. Yesterday, we did another Hood live stream where we answer questions from you. And also, I had the pleasure to talk to our field leads at Solo, where they've been actually talking about ambient mesh to many of our customers before the launch under NDA. So they were able to, educate me on what common questions they heard from the customers and the answers to those. So don't miss out on these two if you're interested in Istio Ambient. Now today we're going to talk a little bit more about ambient mesh, but specifically focus on what does ambient means for your wallet. So I am so excited to have Greg Handsome and also Krisztian. I believe both of them have spoke at the Hood live stream this year. But for folks who don't know them, I'd like to have them introduce. Greg, why don't you go ahead and introduce yourself to the audience?
Yeah, sure. So this is my second hoot. I appeared in one a little earlier, introducing a nice little OnGuard UI tool back then. And so today, I've been working on Ambient since I started at Solo, back in March. So feels like a long time ago, but not really, not even 6 months yet. And Ambient's been an exciting project. I've been contributing to the Istio community since day one. So going to the ambient model and seeing Sidecar as potentially disappearing from the deployment model is really exciting.
That's awesome. Yeah, I was just pulling out the hood you have. Yeah, so debug Envoy config and analyze Envoy logs. Yes, that's the hood you have. Unfortunately, you have to watch the ads now, but it's getting a lot of good views. So episode 24, if you're interested in that. Thank you, Greg. Krisztian, can you also introduce yourself?
Yeah, sure. Hi, I'm Krisztian, and I think this is my third Hood
Yes,
session.
the third. The first one you had is episode 20,
Episode 20.
one-click upgrade to Istio, which we got 400 views. Congratulations. Yeah, and the second one I think is about eBPF.
Yes, it was
Yeah.
migrating tools to Bumblebee.
Yes. Yeah.
Yeah, it
Cool.
was earlier. I think it was June. Yes, June 14th. Yes, and I'm working in the European field engineering team, and recently I joined Greg's performance test to get Prometheus metrics and visualize all this in Grafana.
Okay, cool. Awesome. So let's dive into what Istio Ambient Mesh means to your wallet, right? So I'll start the way we're going to run this is I'll start asking some questions, but we would love to hear the questions from the audience because that's really, really what makes this interesting, right? I guess the first question I would ask is, in terms of resource usage, right? So what are the key measurements you think we should measure that ties to, the actual payment people needs to pay for their cloud bills?
So typically, when you size your cloud, your cluster for Kubernetes, you want to make sure you're checking the amount of CPU and memory that you need per node to make sure that it's enough for your application just for running, but also under maximum load. So you want to make sure the right amount of CPU and memory is allocated for each of those nodes, and you're setting requests and limits for your applications to make sure those limits are respected. And so with Ambient, one of the big savings there is just being able to eliminate a bunch of resources that you no longer need to keep track of.
Yeah, definitely. Yeah. So can you clarify, I noticed in your blog, you talk about allocation and utilization, which I believe are critical concepts in terms of what you actually paying. Can you clarify, which ones are you measuring?
Sure. So we have a Grafana dashboard, and that's published on GitHub. It's linked in the blog, and it's the one that we use for collecting the images that are displayed in the blog there. And so most of those graphs are tracking utilization, so memory and CPU usage during our little scale and performance testing with Fort.io. So that's utilization. What are the pods, containers are actually using while we're sending all these queries through Fort.io and HTTP then. And then there's allocation. Allocation goes back to what I mentioned earlier when you initially size your cluster, because at the end of the day, that's what you pay for on a per monthly basis for your cluster is what its size, how many CPU and how much RAM you need to keep your cluster running on a day-to-day basis versus the utilization, which is what is currently in use. So even if you're only currently using like 15 to 20% of the resources per node, at the end of the day, you're charged for what's actually on the node total.
Mm-hmm. Yeah, makes sense. I purchased my laptop. While I'm sleeping, I'm still paying for it, right? Because I purchased the whole thing, regardless how it's used and how much percentage is being used. Okay, very cool. And now, as far as measurement, what are the key components that's taking consideration for measurement? I assume it's a Z-tunnel and Waypoint proxy.
Correct. And I don't know, Krisztian, if you want to step in and speak about some of the specific metrics, but yeah, for the most part, the containers that we're watching all have are conveniently named Istio proxy. So in the sidecar example, that's going to be the sidecar Istio proxy Envoy containers that run along inside each pod alongside your application containers. And then in the ambient scenario, those Istio proxy containers account for the Z-tunnels deployed in the Istio system namespace. You have one of those per node for your Kubernetes cluster. And then it also keeps track of the Waypoint proxies, which are deployed at the namespace level per service account. Mm-hmm. And so those are the metrics, the specific containers that we're kind of watching while we're running our performance tests.
Okay, makes sense. Yeah, so essentially we're measuring how much resources it's being used during sidecar when you have it running within your application pod, was in ambient when you are running with the Z-tunnel, and then potentially optionally you're running with Z-tunnel and the Waypoint proxy, right? So you were comparing all that. Yeah. Okay, that's very cool. That makes sense. So can you share a little bit about what you discovered as part of this exercise? I think now we have a good understanding of what are you measuring, and now we're trying to understand, what is the findings.
Sure. And I don't know, this is an interesting little tidbit that I ran into immediately when I started setting up my scripts for collecting this data. Lin, could you share my screen?
Yeah, is that your screen that has the StreamYard? Okay, perfect.
Let's see. Yep. There we go. All right. So when I first deployed my cluster, I just thought, oh, I'm testing things out. I don't want to cost Solo too much money, so I didn't think too much about sizing. And so I created this fairly small cluster, and I decided to test against book info. just because that's the Istio staple. So you can see in this environment, I have the pods deployed. They have a sidecar injected. So this is the classic sidecar scenario. And immediately when I tried to scale upwards in my cluster for book info, I noticed that a lot of my pods got stuck in pending pretty quick. I was not checking to make sure my pods were actually running before I was driving load through them. And I was wondering why my results were unexpected, and it's just because I didn't have enough requirements just based on the limits and requests that are in the pod specs for these additional containers. So I couldn't even scale beyond one instance of book info. So I immediately had to go back and deploy another cluster because, so if I just...
How big was your cluster again?
Let's see, I think I just used a 1 to 2 vCPU, maybe 24 gigabytes RAM.
Okay, got it.
Yeah. And yeah, I can run through an ambient scenario, but yeah, I started with running against ambient, and I was able to scale there fine, just for the sake of collecting some initial data. And then, but as soon as I tried scaling with the sidecar example, I started hitting problems pretty quick.
That's really interesting because so that shows like the reserved, right? The sidecar didn't pass the reserve test for your cluster, so you got all your pods appending because the sidecar is effectively asking for more resources just at the reservation time.
Yeah, so let's see. The Istio sidecars, they have a request and a limit for CPU and memory. And at any given point, when you deploy a new container, it takes a look at that request and compares that against utilization in the entire cluster. And if you have the space to deploy a new pod plus that requested amount for that given resource, it goes through. But if it doesn't, it gets stuck in pending.
Yeah. Interesting.
And if you guys want to see it, I can show just a little scale thing of ambient, or I can just run through a quick little test of the actual performance script that we ran to collect this data. If people are interested in trying this against different scenarios in their environments, I can do that.
Yeah, so if you can maybe show the quick test you run, I assume it's relatively automated that you just kick things off. That will be interesting. And also explain to us what are you running in the test. I think that will also be very interesting.
Okay, so yeah, right now I just have, this is my config YAML. This is everything that determines how the test is run. Specifically, here are, let me increase the size here for this, for people.
Thank you.
Yeah, there we go. All right, so the params here are what eventually get fed into Fort.io. We're only doing one concurrent request, that's -c, and this is queries per second, that's just 10, and time duration, since I just want to show you guys the full test and the pretty output, I'm only running it for about 5 seconds. And so there's 3 scenarios that I'm running through. One is sidecar, which is the classic Istio example. And then there's ambient with only L4 enabled. So that means only Z tunnels are deployed. And then finally, there's ambient with L4 and L7, which includes Z tunnels and the L7 Waypoint proxies. And then some of the other toggles here, we have test wait. You can add a little duration to sleep between each test. That helps make a clean line between each of the scenarios when we start viewing the data in Grafana.
Yeah.
And then we also have the server scale factor, which is how we're going to determine how many instances of a given server, in this case, HTTP bin, which is what we use in this test to scale up to for each of those. So I am just going to kick off the test. And let me just double check Yep, pointing to everything. And so with the config YAML, the only thing that you need to do to get running after you pull it from GitHub is just enter in your own cluster context here.
Mm-hmm.
And it's already set up to use the hub and tag of the publicly released images for Ambient. And so I'm just going to kick this off with just run test.sh.
Yeah. So I think, Greg, you also mentioned everything is in the GitHub, right? What you are showing, other people can reproduce it through the GitHub. And I think what you are doing is useful to help them not only calculate the potential cost, but also help them to kind of size their sidecar and the Zeta node and also Waypoint proxy, right? Particularly for the application, the workflow they have in mind. So there's a value in that too, because what you're doing is with booking flow, but I assume our customer or users may have some other applications they would like to run in production.
Very true. And on my screen right now is that GitHub link. Once again, it's linked in the blog. And yeah, you'll be able to clone this and run it yourself. And feel free to share results. And I know one of the questions that I was expecting to come up at some point is, why did we use HTTP bin in our results collection here?
Mm-hmm.
And the answer is, I couldn't get Fort.io to really hammer book info. I'm assuming it's just because book info was not made for performance in mind. It makes for a very nice use case for demoing service mesh, but it's not made to handle that many requests per second over that long period of time. So instead, I just went to something fairly lightweight, just because I didn't want the actual usage of the application pod to take up too many resources. I wanted to keep that pretty small and light, just to highlight the actual usage of the Istio data plane resources. So
Yeah,
just
that makes sense.
Yeah, so just kind of circling back to the test here, you can see it's running. So right now it's just running the sidecar scenario, deploys the control plane, it deploys all the applications, it calls HTTP bin for a certain number of seconds at so many queries per second, and then it calls V2 and V3, and then it cleans up and starts off the next scenario, which is the Z tunnel. So I forgot to account for the time that it takes for the control plane to start up in the actual test run. So we're only about halfway through right now. But so this will eventually run, and then we'll get a nice output of the timestamps for the start and end of each of these tests. And we'll be able to input those into a nice Grafana dashboard. So we can see the three scenarios in this case side by side, and how utilization compares between those three.
That's awesome. So it's a sidecar with Z-tunnel without Waypoint proxy, and then Z-tunnel with Waypoint proxy.
Correct. And just for the sake of time, since this test is still running here, I should have an output since I apparently never clean up my console history. Here we go. When the test is all said and done, you get a nice little output like this. It shows the name of the test scenario, start time, end time, names for each of the scenarios. And so when it comes time to pulling up a Grafana dashboard, you have your start and end times for a specific scenario, or you can highlight the start and end times of the entire test here, and you can see all three of those side by side.
That's awesome. So I guess if we want to see the Grafana dashboard, which I assume you have the data from your previous run, can you share with us how to analyze the data?
Oh yeah, we have a dashboard ready. Krisztian, you want to take over?
All right. Let me bring Krisztian onto the screen.
Share my screen. Okay.
Yeah.
Now you should be able to see this. So basically, these are the three scenarios that Greg mentioned. this first run is for the regular Istio sidecar test. The second one is running with Z tunnels, so level 4 only. And this third one is with level 4 and level 7 with ambient. And yes, you can see that the first two panels are the same as the next two. And that's because if you visualize these in a stacked manner, then you can easily see the difference between the number of the resources that you have. So for example, as you can see in this first scenario, you have a sidecar next to all of your workload pods. And if you go to ambient and use L4 only, you only see the Z tunnels that are the additional resources next to your applications. And of course, you have a few more if you are running with the Waypoint proxies, but you can see the actual change in terms of resource usage across each scenario. And after
Very
this,
cool. Yeah, very cool. We have a question from our audience. Hey, Ahmed, thank you so much for joining us. Yeah, in case of layer 7 Waypoint, by the way, Waypoint, they're together. Waypoint, do we need to ensure Waypoint multiple pod per namespace to ensure HA, especially in multi-zone scenario? That's a great question. So, does any of you want to take that, or you prefer me to answer it?
Well, the entire point of the Waypoint is that it's separate from the pod, the actual application pod. So it can scale independently for the application pod for HA. I'm not up to date with the latest design doc. Do we have scaling the Waypoint proxy defined in the ambient scenario yet, Lin?
Yeah, so last time I checked, so the way you stand up a Waypoint proxy is using the Kubernetes gateway resource, right? So last time I checked, I don't recall seeing a place to specify replicas, specify how you want to place the Waypoint proxy. I think that would be involving upstream how to do that. The current API, at least based on my last time look at it, which was a few weeks ago, I don't recall there is a place to allow me to configure that. But ideally, with the right API, you do want to kind of place your Waypoint proxy, have high HA, right? You do want to try to place it maybe on different node, right? Because if one of your node goes down, you still have your Waypoint proxy on another node. Greg is absolutely right. The way the Waypoint proxy is designed is it's supposed to be running outside and have different scaling characteristics than your application pod. So you would have a lot more control to scale that with your differently than your application pod. So that's a great question. I hope that answers your question. If not, do let us know in the comment on the side. Another question from Ahmed is, if HTTP test based on GET, how ztunnel behaves in case of post with payload on the body? That's a great question.
Yeah, and I do know Fort.io has that option to pass in a post body. We unfortunately didn't run the tests with that. Yeah, it's a good question. And the other thing is right now, this is just relying on basically the Kubernetes name routing. So rather than, say, creating a virtual service for routing between HTTP bin version 1, HTTP bin version 2, and version 3, we're just calling those services directly, just based on their fully qualified domain name. So we basically didn't want to have to change a virtual service between each of the tests and get a little bit of spike from Istio and each of the ctunnels and Waypoint proxies or sidecars as they receive a brand new config every time a virtual service changes. So that's something else that this test doesn't cover. This is just supposed to kind of test it under load. request load, that is. But yeah, the post behavior would be interesting to see for sure.
Yeah, so just to add to what Greg said, so ztunnel can process, right? But ztunnel doesn't try to differentiate get or post, right? ztunnel doesn't passing headers, right? So it doesn't really do anything related to layer 7 processing. So that's the job of the Waypoint proxy. What ztunnel does is to upgrade the connection, right, using the Edgebone connection and make sure that's mutual TLS and then send the traffic with the right, mutual TLS handshaking, the identities. And then if you need any layer 7 proxy, you would have to do it in the Waypoint proxy.
This is very important, I think, because originally before ambient mode, you could also adopt Istio gradually, but with this new ambient mode, you can, and if you are only interested in layer 4 capabilities, you can start only with these and check this out. And if you need any additional capabilities on top of layer 4, you can add those as well. And yes, as you can see on these graphs, the performance savings are quite significant.
Yeah,
if you are only using layer 4.
A lot of people are only after the auto MTLS feature between each of their services. And if that's all you need, ztunnel creates a much smaller footprint. And just looking at the Grafana dashboard there at the bottom, yeah, you can see the resources cut down to size when you only run with that ztunnel.
Yeah, I feel like that if there's a one thing, like the biggest innovation of ambient, I do think separate the layer 4 and layer 7 is the biggest innovation in ambient, right? So we kind of talk about from the resource perspective, but I think also if you look at the upgrade, if you look at CVE, right, how often do you need to upgrade? The layer 4 tier is it's doing much less work, so it's much less valuable. The need to upgrade is much less frequent than layer 7, so that's really, really cool too. Because I know, Greg, I think you are the Istio product security work group co-lead, right? Most of the attest me, right? If most of the Envoy CVE we have in Istio are related to layer 7 processing. Yeah. All right, so Krisztian, let's go back to your dashboard. Is there anything else you want to show? Because I know you were trying to show something, but I also want to bring the question from the audience. So just want to make sure you've shown what you wanted to show.
Maybe it's interesting to mention that these max graphs in the middle are only here to get the actual local maximum during each run. And if you are running this at home on your own laptop or on your own cluster, make sure to change the interval to get the actual maximum value. I think my local port forwarding might be okay, but we get it. So basically, these are tailored to the actual test length that we have for each of the runs. So if you are performing shorter or longer tests, make sure you upgrade these values to get the proper local maximum. We really just use these to get some idea about the actual spikes that we might have, and these can also help you to size your nodes under your Kubernetes cluster. But the most interesting graphs, I think, these 4 and the last 2, where you can actually see the cost savings that you can have running multiple scenarios.
So Krisztian, I assume you are put forward into Greg's cluster, and then you are referring to a test run that Greg ran from yesterday. Is that right? That window we're looking at?
Yes, exactly. I think that's the exact run that Greg just showed us on his terminal. It's the one from yesterday evening in UTC time zone.
Okay, makes sense. Yeah, Greg, were you going to chime in with something?
Oh, I was just going to say, in regards to the I guess, the CPU graph right now, that initial spike from the U proxies is throwing off our max calculations. And it's worthwhile to point out that Ambient is still actively under development. And these are things that we definitely want to, smooth out performance-wise going forward. But it is interesting that the average is still lower in both of those scenarios. So if only we can resolve that little spike at the beginning, our max graphs would be looking a lot better too. And
okay. Yeah, so with that, I actually have a question, because I remember reading your blog. At the end, you said it's about 75% savings, right? So when you give that conclusion, that's the state of Ambient today, and that's considering the spikes at the beginning. Is that true?
Correct. And the savings aren't necessarily just in utilization. This goes back to that utilization versus allocation item too, because you are allocating your cluster for underload values. So even if you're not necessarily using the maximum of those values, what you initially size your cluster for is what you're charged for. So the savings are still there because you don't need to account for this many more pods requiring this many more resources at maximum load. So even if utilization results are not where we want them now with that like U proxy spike there at the beginning, the savings are still there.
Yeah. Yeah, because the number really adds up with between 30, which is your sidecar case, with just a few Z-tunnel and a few Waypoint proxy, right? So that really, really adds up.
Yeah, and those
I really like the diagram, by the way. Great job, guys.
Yeah, good call, Krisztian, adding that stacked graph, because that's really good at just highlighting you need this many more resources to run in the sidecar environment versus the ambient models.
Yeah, it really helped visualize that. Okay, so we have more questions from the audience. I just love how much you guys come up with questions. So thank you so much for the question. So Daniel has a question. Have you done any testing with gRPC? Greg, I'll let you answer that.
So let's see, these tests are not highlighting gRPC. These are just HTTP requests. I know, so the GitHub repo that I linked to actually has a whole host of performance testing analysis. My blog points to a specific branch, which is just pointing to how to run it to get the same results that we have in the blog here. But we have a wider range of HTTP and TCP available there. I don't think gRPC is there yet. I think Google has done gRPC testing, but I don't think we have. I know I personally don't have those results on hand.
Yeah, I mean, I guess the other question to ask is, does Fordio supports gRPC, right? The key thing is what's being presented here lays the great foundation for other people, Daniel, maybe you, if you're interested, to kind of modify it for something else, right? Like gRPC. You just need a client to be able to drive gRPC load, which if Fordio supports, you can use it, or if you can have some other clients. But the dashboard to help you visualize, the scripts to help you kind of, kick out the load and have the 3 scenario and compare, I think would help to expand it to gRPC.
And Fort.io also supports gRPC, so you can run this test yourself, and maybe even create a pull request against the repo, so we can include all these different scenarios. Also, the other question about the post request with the body. Those are
let me
also
bring
interesting.
that question. Yeah. So thank you, Daniel, for that question. So we would love a pull request if that's something really interesting to you, and we would love to hear your feedback when you happen to run the test to see if your result is different than what we have run. So Krisztian, I think you are referring to this this concern about post. Is that right?
Yes, exactly.
Yeah. So
That was
let's
the
get
question.
to it. Yeah. So what's your thoughts? I'll take your thoughts first before I say anything. So the comment from Ahmed, let me read it. My concern about post is if all encryption handled by single Z-tunnel pod, if east-west exchange post with relative large body, this will cause latency, particularly for AI situation with big data, right? So I guess Krisztian, if you want me to chime in first, I guess I would say, you're not going to have all your encryption handled by Z-tunnel, single Z-tunnel pod, first of all, right? So if you have very large load, and if you have multiple clients, so Z-tunnel is only handle application pods co-located on the same node, right? So if you have large traffic and if you have multiple clients pods, application pods, you most likely you will have multiple Z-tunnel handle those. So that's the number one. Now, if you're talking about one single application pod who is sending large body, which you could, right? So that it will be handled by that co-located Z-tunnel. So you're right about that. But this will be similar as Sidecar today, right? Because Sidecar today, you also kind of having the sidecar to kind of do the encryption, do the mutual TLS upgrade for you, right? So this is not much that different than the sidecar case, other than the Z-tunnel would actually handle multiple pods co-located on the same node.
And if I'm right, Z-tunnels are not terminating TLS as well, right?
That's a great question. So the source Z-tunnel would send the traffic on behalf of the client, right? So if your client, say for instance, a sleep, so the source Z-tunnel would send on behalf of sleep using sleep's identity, and then the target depends on what target is. In the case of the second test, which the target is the target Z-tunnel, the target Z-tunnel will terminate, right? That's what Z-tunnel does. Once it's terminate, so first of all, Z-tunnel knows where the target Z-tunnel is because Istio control plane tells Z-tunnel through the configuration of XDS of Envoy today to kind of figure out which other Z-tunnel you should send this traffic to reach to your target. So once the traffic arrives at the Z-tunnel of the target, the first thing it does is actually terminate the connection, and then determines, where the original destination is on that particular node, and then forward the forward the traffic to the original destination, the pod that can serve the original destination traffic. Greg, do you want to add anything?
Oh, it was just reminding me to, I've been with Istio for a while, and I know one of the issues that I handled back when I was still at IBM was a large file transfer.
Oh,
in
yeah.
terms of, yeah, there are some bugs with getting that to work for the entire file to transfer. It makes me wonder how Z-tunnel performs in that type of scenario. Just another interesting case that we could potentially test, and I'd be interested in seeing the results.
Yeah, I think that's Ahmad's concern because I remember I was also at IBM working with you on that. We ended up having to make a configuration change to Envoy to make sure it can send the large bytes, right? I don't recall, was it post or get? It might be just a get, but I guess it's a similar problem too, right? Yeah, when sending large body, well, maybe Envoy couldn't even handle by default. Yeah. Yeah, I remember, I think we had to do an Envoy filter and then change the payload size somehow, yeah, to get it through.
But
Yeah, but
yeah, I would be very interested to see how those two cases actually compare in sidecar versus ambient. So if
yeah,
you have a scenario and you want to test it, definitely share it, please.
yeah.
If you beat us to it, that is.
Yeah, I think it's a valid concern, Ahmed. So yeah, not something we have tested, but I don't believe it would handle much different than sidecar today.
Talking about previous pain points, I think I'm interested in how the ambient mode performs with short-lived jobs, cron jobs, because I remember those were quite painful with regular Istio. You had to hack pre-step hooks into the container configs to make these exit on time. So that's an interesting use case.
Yeah, that is interesting because I know for a long time, Istio with Sidecar couldn't support jobs, right? With Ambient, we certainly do think it will support jobs because the Z tunnel is going to capture all the incoming and outgoing traffic for any pods in Ambient, regardless whether you're running short-lived or longer-lived pods. Yeah, definitely something needs to be tested, but we do think Ambient is designed to tackle that problem as well, along with many other application problems, such as stateful sets, such as server speak first protocol. Yeah, many of the issues we do expect to resolve with Ambient. Just needs more testing too. Yeah. All right. Thank you so much for that question, Ahmed. We really appreciate. Now, let's see. Is there anything else you guys want to share? We talk about the test scenario. We talk about resource calculation. We talk about the resource utilization and reservation. We talk about the test and the timestamp and how to plug in to see it in the Grafana dashboard. And what would be your key takeaway? I guess that would be the next thing I want to ask before we end this live stream.
Well, for me, I think the key takeaway is definitely that top and bottom graph on the Grafana dashboard. Just because you are eliminating that many more resources in your environments. So the savings are right there.
Yeah, because that's the total, right? Was that the total including the control plane or was it excluding the control plane?
So let's see, the green line is the total of the workload usage for the testing namespace that the scripts are running against. So that includes HTTP bin usage and their sidecars and the data plane. Whereas the yellow line on the bottom is just the data plane. So in that first hump there, that's specifically all the Istio proxy sidecar resources. And once we get into that second and third scenario, we have the Z tunnel from the Istio system namespace added in there too.
So it is everything then pretty much from Istio control plane to data plane to the application pods.
So it's not tracking the Istio-D pod.
Istio-D is not in it.
Yeah.
So excluding Istio-D. Oh, so you have the gateway, other stuff. Oh, the Z tunnel is in the Istio system. Okay.
Yes, yep. Basically we are tracking all the containers with the name Istio proxy, and basically the first query is just for the test namespace. but we added this other one as well, because in the Istio system namespace you have the other Istio proxy containers, which are the additional resources that Ambient has.
Okay,
But
got it.
Istio is not included, only the sidecars and the data path resources, let's say.
Yeah, makes sense. Yeah. Very cool. Yeah, what is your key takeaway, Krisztian? Do you share the same or?
Yes, I think these savings are really
Yeah.
great, and the jobs, the jobs and the promise that you can have sort of Istio injected jobs and have all the benefits than before, but now you don't need to hack into the container config. That's really an interesting thing, and
Yeah.
I think I will try this out myself as well, because I have some painful memories with jobs.
Yeah, totally. Oh, one last question. So the premises you have in your demo, that's not part of Ambient, is that right?
Correct.
Okay.
Krisztian, I don't know if you want to take that, since I know I got the steps for installing it from you.
Yes, sorry, could you repeat the question?
The monitoring stack which you are showing, right? The Grafana, the premises, they're not part of Ambient, is that right?
Yes, that's right. You can
okay.
find the instructions to install all these under the dependency section, and basically we are just using the kube Prometheus stack. That's fairly common across Kubernetes clusters. We have this simplified values.yaml file, and yes, that's basically it, because once you apply these configurations, you will have node export LC advisor and all the required configuration deployed to be able to reproduce these in your own environment.
Yeah, so this is actually the reason I ask you this question, because I believe this is another value Ambient provides, right? Because if you guys use Istio today or before, you will know that having premises as part of Istio or the monitoring stack as part of Istio, and having the mutual TLS between your application part to your monitoring stack is not a simple solution, with not a simple problem to tackle in the sidecar world. With Ambient, certainly where you are not running your monitoring stack in Ambient, but I do think Ambient is going to be a lot easy for you to run monitoring stack inside of Ambient, so that you can secure that communication with mutual TLS between your application part to the monitoring stack.
Yes, I think up until this point, people usually do the easiest way and have the monitoring namespaces not injected. And if they were using any stateful sets like this, like Kafka or Tenos, those were running without the sidecars, because it was just easier, and the complexity was too high. If you have a CV, you had to upgrade your monitoring stack. That's a mission critical component that you need to schedule. So it's much easier with Ambient to run all these workloads, which is really great, I think.
Yeah, that's like a huge benefit of Ambient. Yeah. All right. I think the time is up. It's been really nice talking to both of you. I think I have a better insight of what you guys are doing and how you are measuring. What is the net key summary. I think everything is exciting as it is with Ambient in terms of resource usage and the cost, because we're looking at 75% saving, and that's even with I guess the initial release when it's still alpha-ish. So as the team optimize the Ambient code, which we have a laundry list of things to do, I do expect the number will be much better than what's been presented here. All right. Thanks everyone so much for joining us today. We really appreciate, and thank you for all the questions. And thank you, Greg and Krisztian, for coming up the hood and do a live demo and talk us through your journey into these numbers. We really appreciate them. Thanks everybody. Bye now.
Thank you for joining. Bye.
Yeah, thanks everyone. Bye.